So our talk, the post is going to be on Lyapunov exponents and adversarial perturbations. So the goal of this work is to kind of establish a link or a bridge between chaos theoretic analysis of time series signals and adversarial perturbations. We have an ansatz that the adversarial perturbations look different in the sense that the chaoticity that they introduce onto the image or onto the flattened time series has a very specific signature that can be used to kind of pre-detect these adversarial perturbations before they hit the deep net. So it's not like we're trying to propose this as like the flagship defense out there, but we're trying to basically introduce ideas that are very prevalent within the domain of chaos theory and chaos theoretic analysis of time series signals and adversarial perturbations. And that's you can actually use the QR code to basically link up to the GitHub source. You can actually reproduce all the results in the paper. We have like a couple of IPython notebooks with all the code and the plots. So please do visit the poster.
Okay. Hi everyone. Sorry for the slide because I only have 1 minute and I can only make one slide. And my professor is overseas, so I really cannot hold back my urge to make this. So my research is on the invertible generative adversarial network. So the current problem of the current generative models are they are not invertible. So we cannot control what they can produce. We know they can generate something, but we can hardly make any application of them. So there were attempts to do an invertible generative model such as adversarial autoencoder AAE and the variational autoencoder VAE. And we built our model called FAAE, which is flipped adversarial autoencoder, and it's a smaller, simpler, more concise model and more elegant model. So we can see and our performance is better than the performance. That's why I put the Tom and Jerry photo here. Yeah. So there are a lot of applications I put on my poster. They are denoising and morphing and something else. You can check out my poster booth later. Thank you.
Hello everyone. I'm Peiyao Sheng from Shanghai Jiaqi Tong University. And my work is about noise data augmentation for speaker recognition using conditional generative adversarial network. The main problem we want to solve is the mismatch of the speaker enrollment and recognition scenarios. And the motivation of this is to enhance the noise robustness. And most previous work is adding the noises directly to the speech, clean speech. So, but it's not, but it doesn't accord with the real physical conditions. So in our work, we're using the framework of conditional generative adversarial network, peaks to peaks, and to create the noise data according to the condition on the clean data. And the more details about, I'd like to share more details about this in the poster session. And thank you.
Hello everyone, I'd like to introduce my work, a try at task-based dialogue building. Louis is a platform that developers build language understanding models and in specific domain, and you can apply it in HTTP service. And what I want to do is to change the UI of Louis to a program, which means users can define much more things as long as they want. And I wish it to be a more efficient and convenient tools to users. And I also want it not only to be a language understanding model, but also a full, complete dialogue building models. And our first solution is to transform it into a classification problem. However, and we offer the program I written to the users, and they only have to fill in what they need. But it needs the users know little things about programming, and it seems not intuitive to the users. So I think users may prefer chat flowing much more than programming. And what we are doing now is doing dialogue building over knowledge graph, and users only have to offer a knowledge graph on specific domain. Thank you.
Hi everyone, I'm Lun Wang, and in my research, we focus to validating the existence of privacy leakage in long short-term memory in practice, and also we want to launch an attack against it. And we prove that if you have some private information in your training text, then the long short-term memory is very likely to give it out during sampling. And an adversary with some set information can launch the attack very easily and is very likely to reveal your private information. And yesterday I received some very interesting comments about my research, like if we can do this with a classification task, or if we can do this without the verification process. So if you have any questions about my research, or you just want to talk about the food, please feel free to go ahead. Thanks.
So hi everyone, my name is Qingrong Chen from Shanghai Jiaqi Tong University. So in our paper, we are just trying to build a generalized method for protecting the training data privacy and defending those existing attacks. In our paper, we have mainly considered like 3 existing attacks: the model inversion attack, the membership inference attack, and the most recent, the collaborative deep learning with attack with GAN. So we believe the best way to protect the training data privacy is just not to use them, so that the attackers have no way to infer the training data privacy. But we also have to notice that to train a machine learning model, especially in deep learning, will require a lot of data from the users. So facing these 2 contradictions, we have come across a compromise. Instead of using the original data for training, we will firstly try to distort our training data, and then we will use the distorted data as our new training data. In this way, we want to make sure that even though these attacks can be successful, the attackers can only get the new training data. So as long as we can make good distortions between the new training data and the original training data, we can make sure the gains the attackers from the gains is limited for those attackers. And as for designing such distortion function, we have proposed 2 methods. The first method is based on the influence function, which was recently developed by Pang Wei and Percy Liang in ICML 2017. And in that paper, they just give a theory proof of how the distortion of a training data will impose the influence onto the final predictions over the test data. So actually here we want to see that we are actually doing the opposite of creating adversarial examples. Actually, influence function can also be used to generate adversarial examples. You can use an influence function to find those sensitive features and twist these sensitive features a little, and then we'll trigger a big difference into the final system. We are trying to do the opposite. We are trying to find those insensitive features and add a lot of noise, so that create a large distance between the distorted data and the original training data. And as this way has very high computation complexity, so we have designed the second method of using autoencoder as our distortion function. And in this way, we'll just use the encoder part of this autoencoder to encode the original data into the distorted data. And we have successfully proved that based on these 2 methods, we can preserve the utility and the privacy at the same time. And then we have also shown that our method is robust enough to defend against all the attacks I have talked before. Thank you.
Hi everyone, my name is Jiaqi Tong. I'm from Fudan University. My work is about how to generate adversary example for image captioning model. And here we take Shen model as an example because this model is a state-of-the-art neural network model in this field. And we conduct 2 kinds of adversary attacking. One is non-targeted attacking and another is targeted attacking. So in our experiments, we use the gradient descent method to generate a data set for adversary examples according to the Moscow data set. And also in our experiments, we proved that we can cut down 40% of the non-targeted attacking, and we also can achieve an accuracy over 90% for targeted attacking. And we proved that adversary example always exists in image captioning model. So if you want to know more about my research, please check out my poster. Thank you.
So good afternoon. So good afternoon all. My name is Alpra. I am from MIT, India. So my research is almost similar to Unified ID. So it's to continuously authenticate a user, but instead of using it as a primary authentication mechanism, it's used as a secondary authentication mechanism when someone gets in way of your primary authentication mechanism. Like Unified ID, we use a combination of sensors to identify the user. We are in the starting stage of the research. There are some issues in that. We use support SVMs to classify the user based on the data from the sensors, and it's pretty. The results from the accuracy is pretty compelling. It's about 94 to 95% of the accuracy. So if you have any queries, I'll be out there during the lunch. You can ask me. Thank you.
Hi, good afternoon, everyone. I'm Meng Xuan. We are a group of researchers from the Singapore University of Technology and Design. So our research focuses on detecting a new type of distributed denial of service attack known as the crossfire attack. So unlike the traditional DDoS attack, where the attacker directly attacks his target victim by overwhelming his target server with meaningless requests, the attacker in the crossfire attack does not target its victim directly by sending attack traffic to it. So the target server has no way to detect the attack. So the attacker managed to achieve this by setting up his attack in a very sophisticated and interesting way. So our research proposed a reasonable and practical location to detect the attack, and we leverage several deep learning models to help us do so. So this is still an ongoing research, and we hope to receive feedback and questions from you during the poster session. Thank you.
Hello everyone, I'm Shiqi. So in the project that we are going to show you in the later post section, actually it's called domain agnostic constraint synthesis. So why we are so what's the problem we are going to solve here? Actually, we are going to generate the constraints, which is a relationship between the specific variables at a specific program location of interest. So without analyzing the source code at all, and without knowing the specific domain knowledge, like the linear algebra or the geometric, which means even for a student from high school, they can easily deploy our approach simply. So why this topic is interesting for us to working on is because actually the constraints that we learn can help the developer to understand what the programs it is. So if the program is very bad written and we do not have any documentation at all, the constraint we extract here actually can let them know what the property that will be held at this point. Moreover, it can also be helpful for us to detect the buffer flows and integer overflows and fix the problems in it. So if you are interested in, please come and see our poster.
Hi, I'm Theodora. So what is type recovery? Type recovery is an intermediate step in decompilation, which is the reverse process of compiling source code to binary. Why are we interested in this? There are several reasons. For one, you don't know if the source code that you're writing is actually going to be executed, so you don't trust the compiler because it may introduce backdoors. Another problem is that you don't have access to the source code, so you only have access to the binary, and you want to do something like malware analysis or binary analysis. There are several challenges. This is a very well-established problem. One of the challenges is that it's architecture and compiler dependent. Another problem is that you have code obfuscation. You also have compiler optimizations. And you have lack of higher semantics because during compilation, these are removed. So we propose to use deep learning to do type recovery, and we also want to reason about what the model has learned and get some typing rules for the specific binary. Please come to our poster to see what are the challenges in using deep learning for this problem. Thank you.
Good afternoon. One of the main aims was to build a Hadoop which is secure and preserves a end-to-end privacy. For that, we used one of the recent information flow control models, readers writer flow model, which enabled us to generate the labels automatically, and then plug all the flow, so there is no information leak in the Hadoop system without much overhead, and this has much superiority over some of the current attempts like Irabat etc. kind of a framework or the other. So it totally preserves the privacy in the original data, even if you execute on a MapReduce or a Hadoop framework. Thank you.
Thank you. So hi everyone, I'm Mathieu from Secure IC. So Secure IC is a company providing security technologies for embedded systems. So this includes autonomous vehicle, IoT, smartphones. And so we help chip manufacturers and device vendors to protect, evaluate their service to reach the highest level of certification, security certification. So in this research work, so actually we base all our technologies on research also conducted with Telecom Paris Tech, because we are a spin-off from Telecom Paris Tech. And so in this research work, we show in practice how to select and improve side channel analysis, which is the most threatening attacks on embedded systems with machine learning techniques. And so other similar research we conduct include finding, recovering secret key from ECC crypto systems with deep learning or from the from power analysis also. Thank you. So my poster is outside. Please reach me if you have any question.
I think that's all, so I don't miss anyone, right? Okay, then we can. So that's the end of this lightning talk, and the posters are outside here. We will host the poster session along the lunch, right? So okay, then I think it's ready for lunch.